It will be on to start. So we can hear you. Hold on, audience. Good evening. You're muted, sir. You're muted. Good evening.
Good evening, sir. Can you hear me?
How are you?
I'm good.
Great to see you, especially on a precast of Dr.
Good to
A.R.
see you.
Well deserved occasion for you. Appreciate your efforts.
Yeah. Thank you.
Thank you. I love to watch you.
Good evening to your son also.
Thank you. Yeah, he's there. Thank you.
Good evening, Ramana Naik Garu. I just want to check whether I can broadcast my presentation. Just check.
Let it be there on.
I'm supposed to be given permission to sharing. So if Mr. Ratnam is there, he can allow me to broadcast. Ramana Garu, the host has to give me permission to share my file.
We have to allow. Can we record it?
Yeah. If you want, you can record.
Yes. You have to give clearance, huh?
Murthy garu, automatic records, no problem.
No,
sir.
I think Srinivas, good evening.
Yeah, good evening, sir. How are you?
I'm good. Nice to see you.
I'm really great. You are going to address us on the legendary A. Ramakrishna garu.
Yeah.
I used to meet him very frequently when I was in Fosrock. And subsequently, when I moved to Sirakem, he is my neighbor in Anna Nagar.
Okay.
To stay close, just close by.
Okay.
Reddy garu, good evening. KG
Good evening, sir.
Murthy.
How are you?
Fine. How are you?
Fine.
Great to see you after a long time.
Yeah, correct. We met about 2-3 times during my tenure as a chairman at ICI.
Not only that, you are an ex-Araka man.
Taj Mahal Hotel.
Yes.
Sir, today we got a eminent Captain Bhandarkar sir from Mumbai. Pranam sir, pranam. Murthy garu, हमारे senior council member. Pranam sir, pranam sir.
Namaskar sir, pranam sir, namaskar.
Sir,
Murthy garu, namaskar.
Namaskar sir, ladies and namaste.
Namaste ji.
Namaste sir. Namaste.
Murthy garu, namaskar sir. Thank you. Sir, Ratna will follow, share your all PPT sir. Kavya sir.
No problem. Chairman.
I have to be given permission, Ramana Garu. It is not
definitely
given yet.
sir. Already given to, I requested Ratna garu, he will prepare.
Great, thank you.
It still says host disabled participant screen sharing.
Yeah.
You are not admin?
They have to enable that.
Phone secretary దగ్గర ఉన్నాడు.
Yeah.
Before recording this. You can't hear. You can. Nobody's talking. What?
Who is having the admin rights? He has to give me permission to share the file.
Yes, sir. Mr. Ratna will follow in 2 minutes, sir. Coming.
No problems.
Yes, come in. Nobody has come there.
Marisa, Marigaru, Bandar Sahib Janeru, Dr. Murthy garu, KT Murthy garu Janeru,
Okay.
Kalaga Sahib Janeru, their parents just Raskundi, ఎందుకంటే Asset garu, mana KG Murthy garu వచ్చారు.
Namaskaram, sir.
Namaskaram, sir.
Namaste.
Namaste, namaste.
Sir, how is you rains in Mumbai, sir? No rains. Mumbai.
Lot of rains in Mumbai.
Yeah.
Sir, namaskar, pranam, sir.
Pranam, Ramesh garu, namaskar.
How are you, sir?
I am very fine, sir.
Thanks a lot, sir. You spent on our request of our chairman,
you
the dynamic chairman of Telangana State Center. Mr. Ramna, you came to there. You spent valuable time with us. Highly
Sir,
memorable, sir. You are.
Sir, speech was a wonderful speech. बहुत बढ़िया था. We are proud of our Captain Manag, sir. Positive news, yeah. Resource, with this, yes, across the dozen books to have a chill. Let's share. In the Guru Sir, we are going for garlanding, sir. With your permission, we will garland our great engineer and back in a few minutes, sir. Kindly.
Manchuri garu, good evening.
Good evening, sir. How are you?
I am good. Thank you.
Am I audible?
You are audible, visible, bright color.
Good evening.
Oh,
Good evening, sir.
good evening, Nagendra.
Good evening.
How are you, Mr. Anchari?
Yeah. How are you, sir?
I'm
Great,
fine,
great.
thank you. Yeah.
KCK Murthy garu.
Namaskar,
Wow. Sir, namaskara. Nagendra.
Good evening.
Good evening.
Dr. Ranjit Saab.
Yeah, Chairman, sir. Namaste.
Namaste, how are you, sir?
Yeah. Today it's
Sir,
a
good evening, sir.
India program, sir.
Good evening, Anchari, sir, the convener.
Yeah.
Convener. Murali garu, good evening. Sir, Nagendra, sir, good evening. KGK Murthy, sir, good evening.
Good evening.
అది రత్నం గారు ఓరియంటేషన్ మార్చేసింది.
Yeah.
What? Anjali, you have come to Sheraton and did call me.
Yes.
Yesterday we were in Chennai.
You're in Chennai? No, on 27th I will be in Chennai, sir.
I saw it.
We'll meet again. The same place. Chola, ITC Chola will meet. I will send you the invitation. Kalgal sir, you have that PPT to share, isn't it? I mean,
Yes, I have. I checked also.
okay.
It is working.
నేను ముందు ఉంటాను.
పెట్టు నువ్వు ఇది తీసుకుంటూ పెట్టావమ్మా. అప్పులు పెట్టు అప్పులు పెట్టు పెట్టండి గుడ్ అప్పులు పెట్టు ఆఫ్ చేయాలి చేతి గుడ్ ఇట్లా చేయించండి. ఇది పెట్టు రండి ఇంతగా రండి రండి. రమా దగ్గర రాదు.
Permission to record it will not be recording. No, no. You have to give permission.
Yes, sir. Let's going for this thing.
నాయక్ గారు అది రికార్డింగ్ చైర్మన్ గారు
Yeah.
అది ఓరియంటేషన్ చేంజ్ చేయరా, అది ఇట్లా క్రాస్ కనబడుతూ ఉంది.
సార్ సీజ్ చేయండి రికార్డ్ సీజ్ చేయండి కెమెరా సీజ్ చేయండి మీరు బ్యాక్ రండి.
స్టిల్ చేయాలి.
యా క్లియర్గా క్లియర్ చేయండి.
You have to give permission.
90 degrees స్టిల్ చేయాలి.
కరెక్ట్ రిలీజ్ చేయండి.
ఓకే సార్.
నో 90 degrees ఇది ఇలా రివర్స్ కనబడుతుంది. యా ఎస్ 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 ఎస్
గురుజీ హలో స్మైల్ అనండి.
ఓకే సార్ లెట్ us start. ఓకే let us start. స్టార్ట్ చేయి దా దా.
The host has to give permission for recording. Recording permission ఏ లేదా గురు? Host whoever is.
ఇచ్చే సార్ సార్ ఈస్ గివింగ్.
Hello. Shall I start, Chairman sir? Hello.
ఓకే
Good evening, respected members. Today, the Institution of Engineers India, Telangana State Center is organizing Dr. A. Ramakrishna sir 13th Endowment lecture. For this, the convener of the program, the day is none other than Dr. S.P. Anchuri, committee member of II Telangana State Center. The dynamic and I request, I will be thankful to Dr. M.R. Kalgal sir for gracing this function. Now I request our chairman to continue the program. Thank you.
ఆనస్టెంట్ గారు మనం అది వాళ్ళ న్యూడ పెట్టుదా.
ISS. Pattu Rambaya garu and
ప్రొఫెసర్ లక్ష్మణ గారు,
Professor Lakshmana garu.
ఇంకెవరు ఉన్నారు? రత్నం గారు
వీళ్ళిద్దరు
అంతే సార్.
అంతే ఇద్దరు. చెప్పండి
సరే.
సార్ చెప్పండి.
ఇప్పుడు చెప్పాలా లాస్ట్ చెప్దామా? ఏం చెప్తాం
ఇప్పుడు చెప్పండి.
సో టుడే గుడ్ ఈవినింగ్ ఆల్ ఆఫ్ యూ సార్.
Recording not possible.
సార్
Recording?
రికార్డింగ్ ఆటోమేటిక్ రికార్డింగ్ సార్. రత్నం గారు
Recording. Already it is recording. Live stream.
రికార్డింగ్ సార్, ఆల్రెడీ రికార్డెడ్.
ఇట్స్ ఆన్ యూట్యూబ్ ఆల్సో, ఇట్స్ గోయింగ్ ఆన్.
థ్యాంక్ యూ. యూట్యూబ్ ఈస్ గోయింగ్ ఆన్.
ఓకే సార్, రికార్డింగ్, నో ప్రాబ్లం సార్. Dr. A. Ramakrishna 13th Endowment lecture on sustainable construction. Today, welcome to President opening remarks. Sir, before this, sir, I am requesting Hana Secretary Garu and our Anchuri Garu, Dr. SP Anchuri Garu, and our Chief Guest today, MR Kanagal Sahab, Dr. M.K. Murthy Garu, Bandar Sahab, and all eminent engineers with me, Dr. Srinivas Reddy. And sir, before starting meeting, sir, our two eminent engineers, one P. Lakshmanana FIE, former registrar, senior professor and former registrar of Usman University, and D. Sambe Garu, chief engineer from Warangal Center. Both are passed away, sir. So we are requesting for 1 minute. I'm requesting all of you to join the Mumbai. Present. Rooney. Thank you, sir. Thank you. Johar Lakshmanana Garu, Sambe Garu, Johar.
Thank you.
So, respected keynote speaker and chief guest of today's function, Dr. Manmohan R. Kalgal, President SEWC India, past President ICI, and past Vice President of IE Structures India. Engineer Mari Ramesh Garu, Under Secretary, my friend, Dr. Anchuri Garu, MIE, member IETSCC, and convener of today's event. Galaxy of the eminent personalities, Professor Bandar Kesap, my guru, and eminent CA Prasad Garu, and our Dr. Srinivas Reddy Garu, and అందరికీ పేరు పేరున నమస్కరిస్తూ ప్రసాద్ గారు మొట్టమొదటి వచ్చారు కాబట్టి వారికి ప్రత్యేకంగా నమస్కరిస్తూ మురళి గారు, committee members Murli Saab, and all committee members who joined today's Damoreddy Garu, Chandramouli sir, and our Alam Khan Saab, corporate members and IE family members of late Dr. A. Garu, media friends and ladies and gentlemen. It's given in immense presence to extend a hearty welcome to all of you. The Dr. A. Ramakrishna 13th Endowment lecture on a very important, vital and interesting topic of the sustainable construction, a role of precast concrete. We are very fortunate to have a stalwarts like eminent personalities, chief guest Dr. Manmohan R. Kalgal Ji, President SEWC India, keynote speaker, and today's chief guest of Endowment lecture. We thank him for sparing their valuable time to be admitted to this important event. I am glad to inform that Telangana State Central Institute of Engineers, India has been regularly organizing 22 endowment lectures every year on the birthday of our honor of eminent engineers like Engineering E.V. Subbarao Endowment Lecture, Engineering M. Tirupati Reddy Endowment Lecture, Engineering Professor K. Gopichand Endowment Lecture, Dr. J. Purushottam Endowment Lecture, Dr. Engineering G. Prabhakar Endowment Lecture, Engineering Koka Krishnamohan Rao Endowment Lecture, Engineering B. Anantrao Endowment Lecture, Dr. S. Balakrishna Reddy Endowment Lecture, G.V. Subbarao Garu Endowment Lecture, Engineering T. Hanumantrao Garu Endowment Lecture, A.P. Ranganath Swami Endowment Lecture, Dr. S. Raghavachari Endowment Lecture, Nala Tatarao Endowment Lecture, Engineering Mathur Gopal Rao Endowment Lecture, Engineering Guram Kotreddy Endowment Lecture, Atturi Venkateswara Endowment Lecture, Engineering R.L. Raju Endowment Lecture, in Dr. John A. Murray Endowment Lecture, Dr. N.V.L.N. Rao Endowment Lecture, Engineers L. Venkatekrishna Ayer, K.V. Srinivas Rao, and M.L. Swami Endowment Lecture, Dr. A. Ramakrishna today's Dr. Engineering I. Basavarao Endowment Lecture. The endowment lectures are being delivered by the people of high eminence with considerable professional experiences to throw the lights of the important emerging topics of today's relevance. I say a few words about that our Dr. Ramakrishna Garu for information with the enlightened audience. Dr. Anmol Ramakrishna sir was born on December 28, 1939 at Pudipadu, Andhra Pradesh. He obtained a bachelor degree in civil engineering in 1960 from Andhra University and MSc Structures Engineering 1961 from the College of Engineering, Gundi, Chennai. He started his career in 1962 with the Engineering Construction Corporation Limited, GCC, the then wholly owned subsidiary of the Lance and Turbo Limited. The ECC was subsequently amalgamated with the parent company with the widely known as the ECC Construction Division of L&T. Dr. A. Ramakrishna, former Deputy Managing Director and President of the ECE as L&T. Dr. Ramakrishna is an acknowledged expert in the construction industry, known for the novel systems and processes of the played a central role of the involving policies and relating the construction sector. He has been President of the Indian National Academy of Engineering, INAR, Vice Chairman of the Construction Industry Development Council, CIDC, and Vice Chairman of the National Academy of Construction. He was an independent director in a few companies. Dr. A. Ramakrishna was awarded the 2007 Hasibbi Sarab Award for the Engineering Construction of Excellence, and initiation of the GL Rao FIE donated an award about amount of the 4 lakhs to IEI, APAC to Institute Young Engineering of Excellence in a structural engineering area under the style of L&T. Dr. A. Ramakrishna Young Engineering Award to be presented every year during the engineering celebrations. Due to demise of Dr. Ramakrishna Garu during the year 2013, it is proposed by the State Center Committee to organize the endowment lecture every year. Since you are anxiously awaiting to hear the talk about our eminent speaker, I am limiting myself and hope that you will be really enjoy the talk. Lastly, on behalf of Institute of Engineers Telangana State Center and the Institute of Engineers India and Mohan Bipaf, once again, I extremely heartily welcome to all of you for this important meeting. Thank you, Randall. Now I am requesting Dr. Anchuri Garu to this biota.
Yeah. Namaste, everybody. In fact, it's my great privilege and honor to introduce our esteemed speaker for today's endowment lecture, Professor Dr. Manmohan R. Kalgal, who is also my mentor. He's one of the India's most distinguished structural engineers with over 4 decades of contributions spanning academia, research, industry, and professional leadership. He holds bachelor's degree in civil engineering, master's degree in pre-stressed concrete structures, and a PhD in concrete structures from Indian Institute of Science, one of the prestigious institutions in the country. After serving as professor of civil engineering at MS Ramaiah Institute of Technology for over 2 decades, he moved to industry where he held leadership positions at BBR India Private Limited and later at Ultratech Cement Limited, serving as joint president and head technical services and subsequently as technical advisor. A fellow of several leading professional institutions, Dr. Kalgal has served as past president of Indian Concrete Institute, ICI, past vice president of Asian Concrete Federation, past vice president Southern Region for ISTT, and currently serving as the president of the SEWC, that is Structural Engineers World Congress, India section. His contributions have been recognized with several prestigious honors, including the Eminent Engineer Award from the Institution of Engineers India and the Indian Concrete Institute Lifetime Achievement Award. Now, it is particularly fitting that Dr. Kalgal is delivering the 13th Dr. A. Ramakrishna Endowment Lecture because Dr. A. Ramakrishna was widely regarded as one of the India's foremost authorities on pre-stressed and precast concrete structures, whose pioneering works transformed modern construction practices. And today's lecture on sustainable construction, the role of precast concrete, beautifully reflects that legacy. With this unparalleled experience in concrete technology and structural engineering and the advancement of precast construction, Dr. Kalgal is uniquely placed to carry forward the vision and the professional ideals of Dr. A. Ramakrishna, who championed throughout his illustrious career. Ladies and gentlemen, it is my privilege to invite Professor Dr. M. R. Kalgal to deliver the 13th Dr. A. Ramakrishna Endowment Lecture organized by the Institution of Engineers, Telangana State Center. Sir, the pan-India participants are there, so the virtual floor is yours. Go ahead, sir. Thank you.
Welcome, sir, Dr. M. Kalgal, sir.
Thank you, Anchuri. I hope my audio is clear.
Clear, sir. Both badhiya, sir. Clear.
Okay.
Yes, sir. Clear.
Now I'll present my PPT also.
Here,
Can you see the
Yes,
slide,
yes.
please?
Yes.
Yes, sir.
Okay. So, good evening, everybody. It's a great pleasure to have been invited to give a talk on in the memory of Dr. A. Ramakrishna, who was a guiding spirit and mentor to all of us. In fact, I had the privilege of working with him on the ICI handbook on precast concrete, which itself was a mammoth task. And he, as the leader, showed us the way as to how a handbook is to be made. And he is the pioneer of the construction industry and specifically of pushing the precast prestressed concrete in Indian subcontinent. So I'm privileged and thankful to the Institution of Engineers Telangana Center, specifically to Dr. Ramana Naik sir and Anchuri, as well as Marie Ramesh, and all of my friends who are there from various parts of the country, right from Hyderabad to Chennai to Mumbai and other places. So without wasting much time, I am planning to start my presentation. I am fully aware and humbled that very many of you are more knowledgeable than me in this particular subject. This is only as an opportunity to collect some thoughts in my mind and whatever that I can uh, transmit from the limited knowledge, I'll go through the presentation that I have made. So the title, as you have seen, has two parts. One is the sustainable construction and the other one is the precast concrete and the role of precast concrete in sustainability or sustainable construction. So very quickly, I'll go through some elementary things about sustainability. Sustainability, there are hundreds of definitions. All of them are right in their own perspective. One that I have chosen says sustainability aims to protect the natural environment, human and ecological health, while driving innovation and not compromising our way of life. So when a question is asked, what is sustainable development? Because for human beings, for us in mankind, development is a must. But how to make that development sustainable, or what is a sustainable development? Again, there are several approaches, or many of them are perfect. And one of them that I have chosen is here, a development which recognizes the needs of everyone, which maintains stable levels of economic growth and employment, which uses natural resources prudently while protecting and, if possible, enhancing the environment. That is the definition I have chosen from number of definitions that are available for sustainable development. So people say that sustainable development or sustainable concept is standing on three pillars. One is the social angle to it, the second is the economic angle to it, and the third is the environmental angle to it. So a development which is social as well as environmentally beneficial is called a bearable development. A development which takes care of social issues and economic issues is said to be an equitable development. A development which focuses on environment and economic issues is called a viable development. All of them put together is called sustainable development. So this is the tenet on which the sustainable development stands. Now, all of us have heard about greenhouse gas scenario also. Everybody is now talking about sustainability, greenhouse gas scenario, carbon dioxide emission, ozone layer hole, and all kinds of things. So quickly, let us see the GHG scenario throughout the world. So China is the biggest emitter of carbon dioxide or the greenhouse gas. And greenhouse gas, 26% of the total GHG is emitted by China, followed by United States at 12.5% and India at 7.06%, which is far lower, of course, slightly higher than European Union. But look at the GHG from China and United States. Now, when you also look at the emission per person, because people may say the number of people are, less there, so it might look big and all that. The emissions per person, world average itself is 6.27 tons of carbon dioxide equivalent. Now keep this in mind when you look at other countries now. Canada and United States have the highest per capita GHG, 19.6 and 18.28 tons of carbon dioxide equivalent. Why carbon dioxide equivalent is, it is not just carbon dioxide that we are emitting a lot of gases. All of them are brought in one platform called the equivalent, that is carbon dioxide equivalent. So per person carbon dioxide equivalent in USA and in USA and Canada are quite high compared to the world average. India has the lowest, 2.48, that's all, compared to the others. Okay, what about China? China's per capita emission is around 9.06. This 2.48 and 9.06 is relevant because the denominator, because per person, the number of people who are there in India and China are huge compared to those which are there in America or other places. However, now China having the same as our population is 9.06 ton per carbon dioxide equivalent, and it is continuing to rise, and it is surpassing the values of European Union, that is CO2 equivalent per person. Now, the reason for that can be many. China had a very vigorous construction activity, very vigorous development on all fronts, increasing the amount of carbon dioxide equivalent emission hugely. And though there is a big denominator, they were not able to come down below 9.06. So there are some exceptional countries like Qatar and Australia. While the top 10, they may not be in the list, but they have higher per capita emission, 40.52 and 23.10 ton carbon dioxide equivalent. Okay, let's not bother about who is higher than us, but what is our contribution to the greenhouse gas effect and carbon dioxide emission, and what can we do about it is the criteria. So there is another word which is also popular called decarbonization, which comes from the carbon dioxide equivalent that people are measuring. So the reduction of carbon by phasing out the man-made carbon dioxide emission is the goal. And the ultimate goal is, of course, to eliminate that if possible and make it zero, no contribution of carbon dioxide emissions to the atmosphere by we human beings here. Now, there have been several agreements. The latest one was the Paris Agreement of 2015, which is a legally binding international treaty on climate change. Now, this was adopted in 2021 by 195 countries in the United Nations Climate Change Conference, COP21. And what they have said is they have resolved, and including India, all these 195 parties have signed, saying that they will limit the global warming to well below 2 degrees Celsius compared to pre-industrial level. After industrialization only, they started going up. So keeping that as a datum, can we make sure that the temperature does not go beyond 2 degrees compared to pre-industrial levels is what they are committing on. And they have said preferably 1.5 degrees compared to pre-industrial level. This was signed and agreed to in 2021. Now, the global net human caused emissions would need to fall by 45% from 2010 levels to 2030 if we want to achieve this 1.5 or 2 degrees or limit the temperature rise to 2 degrees beyond what it was in pre-industrial level. So 45 degrees, 45%, you have to reduce the carbon dioxide compared to what it was in 2010 by 2030 and try to reach net zero around 2050. These dimensions have been modified because people have seen that it is not easy. The carbon dioxide emissions from fossil fuels were expected to rise by 1.1, reaching 38 billion tons last year. And the emissions from various other sources are also listed here as coal from 0.8%, oil up by 1%, and natural gas up by 1.3%. Despite the years of climate action, we've been fighting for it, talking about it, taking a few steps in the good direction. Still, the global emissions have not begun to decline. That is the sad part of it. Now, coming to our area, that is buildings and constructions, the building materials are dominating the climate change. How? Let's see. The built environment sector is by far the largest emitter, and it is responsible for at least 37% of global emission according to UNEP, that is United Nations Environmental Program, as of 2023. Now we are already in 26. So the 37%, if we are contributing to global emission, we are to be more responsible from now on. So most of the progress in our sector has been made on reducing the operational carbon. So people have been talking about energy or carbon dioxide emission due to various reasons. So the buildings, when they are built, the emissions created because of heating, cooling, lighting, cleaning, and all kinds of operations is called as operational energy or operation carbon. And all of us are concentrating more on that. However, there is also what is called as embodied carbon. Now, this comes from the design, production, and deployment of building materials like cement, steel, and aluminum. Here, we are lagging behind because we are not taking much steps to reduce these embodied carbon. Only operational carbon, some efforts are on. Both of them need to be pushed much harder. When you look at the carbon life cycle of a building, which consists of several steps, like from raw material extraction and processing to manufacturing of building materials, to transportation and to construction site, to utilization of the material in construction of a building, then operational use of the building, then refurbishment and repair or reuse of the building, then demolition at the end of the life of that building, and possible recycling and disposal of recovered materials. If you look at all of this, there is one raw material extraction to manufacture of building, which is called the cradle to gate contribution. This is something which can be definitely attacked or attempted to be reduced. So there are now understandings and pushes, and even this talk is trying to emphasize the need for us to see that the building materials are attacked as the potential enemies of our climate issues. Now, one of the largest construction materials is concrete, and we are talking today about precast concrete, so I have chosen concrete as the subject. Now, concrete is very widely used, abused, misused, and also less understood. So many people say that concrete is not sustainable because it uses the material called cement, and cement produces a lot of carbon dioxide, and hence concrete is not a sustainable material. Now, this is the general understanding of most of us. Now, if you look at this particular concrete from those parameters which are used for evaluation to the contribution to carbon dioxide emission, is the entire life cycle which I showed earlier, which consists of extraction, processing, construction, operation, demolition, and recycling. If you look at all of these parameters and compare it with all other alternatives that are available for construction, concrete makes a significant contribution to the triple bottom line which I talked about, that is environmental, social, and economic aspects of a sustainable development. Now let us see whether we can make it more sustainable. Yes, there is some component of cement in it, but please remember cement is only 10 to 15% of the total concrete. But then there are other materials in the concrete also. So people are now looking at the possibility of making concrete more sustainable. How to make it more sustainable? Obviously attack cement first. So to make cement more sustainable, some of the approaches are to use less energy intensive kilns at the factory, use supplementary cementitious materials to reduce clinker. Please remember that 1 ton of cement produces 1 ton of carbon dioxide is with the OPC in mind, the clinker in mind. So if it is 100% or 95% clinker, then 1 ton of carbon dioxide, 1 ton of clinker production results in 1 ton of carbon dioxide was true. But that again, people have now, with all the improvements at the factory and resources extraction, have brought it down to about 0.7 tons per ton of clinker. So now use supplementary cementitious materials like fly ash or GGBS or any other materials. Obviously, you'll be reducing the clinker content. So the reduction in clinker factor will make it more, sustainable. So if you take 700 kgs per ton of cement manufacture, if you use 50% of GGBS, then the impact is only 350 kgs now, 350 kgs of carbon dioxide per ton of cement produced. So that's an attempt to make cement more sustainable. Then they are trying to use new types of clinker, which produce less carbon dioxide, use alternative fuels and renewable energy during the production process, and if possible, produce clinker-free cement. So from the cement angle, these are the efforts that are going on. Now, when you look at concrete itself, people are looking at using alternative materials within concrete. Now, what are those? Like recycled aggregates, secondary aggregates instead of the primary aggregates or the virgin aggregates that we are using. Similarly, wastes in concrete, they are trying to use the wastes of other industry as part of the concrete, as this is called as converting of liabilities to assets. So wastes as reinforcement, wastes as special additive is being tried out. They're trying to make concrete more durable. So if anything is made more durable, there is lesser requirement for you to replace it. So you get sustainability through longer lasting structures. This is another attempt that is going on. Then capture and sequester carbon dioxide. That is it possible to capture the carbon dioxide and also mine it, or put it inside the ground in the bedrock and make sure that it doesn't get into the atmosphere, bury the concrete. So this is another approach that is being pushed very hard. Then they are also trying to produce clinker-free concrete like geopolymer concrete, alkali activated reactions, and so on and so forth. Now, while making, that is one cement angle, the other one is concrete, its ingredient angle. Third is the making and using of concrete. What can we do there? Use of appropriate construction chemicals judiciously to reduce the water cement ratio and obtain a dense and durable concrete. That is also something that people are looking at. Then concrete, we all know that concrete made well, transported carefully, cast properly, and cured sufficiently would last very long and makes the concrete more sustainable material. Now, the absence of large-scale mechanization, absence of wave batching facility, improper shuttering, inadequate compaction, virtually no curing, these are the bane of concrete construction, which all need to be focused on. And there is also a need to extensively train the masons and construction workers and create awareness and inculcate professionalism in them. So these are the efforts. And one sentence which puts everything together is the challenge is limited raw materials must be used in a resource efficient manner, and modern living space must be provided in accordance with latest energy guidelines and building standards under cost and time pressure. All of them have been encompassed in this one sentence. So I thought I'll flash it. Now let's come to precast concrete. Now, All of you know what precast concrete is. It is a product produced by casting concrete in a reusable mold or formwork, which is then cured in a controlled environment, transported to construction site, and lifted and erected in place. This is generally a all-encompassing definition of precast concrete. Now, precast concrete is generally an ordinarily reinforced concrete or sometimes pre-stressed reinforced concrete also. So pre-stressing is done to get the advantages of reduced cross-section, steel requirement is reduced weights, and pre-stressing of course needs some additional equipment, abutments, jacking equipments and so on and so forth. But still, a lot of economic benefits and strength benefits are there if you pre-stress a precast member. Now, precast concrete can be either factory made or it can be made even at site. So if it is made at factory, it's called off-site. And if it is made at the site, it is called on-site. Depends on the volume of work and logistics, of course. So if it's a big work, probably you might even set up a precasting yard at the site itself, provided there is space for it. And also it might become necessary if it's very difficult to get anything from outside to the site. So you may have to go for on-site. But factory cast has a lot of advantages and it is preferred because it gives more control to the producer and the designer. He has more reliability or more, belief or trust in what is made in a factory, with better options for pre-stressing, architectural finish, higher grades of concrete, etc. So factory precast is generally preferred. Now, better quality can be obtained as workers and supervisors are well trained and they are experienced, and work is not hampered due to bad weather and such other conditions. Now, why precast? Quickly, let's go through. All of you are aware, but I just want to collate all the thoughts. Most important thing is speed, because the concrete elements can be manufactured under controlled conditions. At the same time, when early works like site foundation work, etc., are being carried out. So just in time, you can bring in the ready-made elements and assemble them at site when the site is ready for that. So he'll erect the components and dramatically the construction time is shortened when you bring it from somewhere and simply assemble it there at the site. So it reduces also the on-site congestion, financing costs, and it accelerates the occupancy date. Then another advantage of precast is the quality and durability. Lasting benefits are there which are inherent. High strength, high density, quality control precast is superior to other building products, obviously. And in terms of durability, corrosion resistance, impact resistance, fire resistance, security, and long lasting, low maintenance, all of these are properties which are superior to most of the other competing building materials. Now, production on the smooth steel molds ensures high dimensional accuracy and superior finish, and the molds are also reused many times, ensuring economy for us. The assurance of concrete product is achieved through environmentally controlled manufacturing condition, skilled workforce, and stringent inspection and concrete testing. So when precast concrete is pre-stressed, as I mentioned earlier, this active form of reinforcing keeps the concrete in compression and minimizes the cracking and increases the load carrying capacity. Another advantage is to have long spans. You can have much. It has increased load capacities, especially if you pre-stress it, and also because precast can be made with higher strength concrete and excellent quality control. It will be stronger and it has higher load capacities and sections are more efficient. Large span floor system leads to more flexibility as internal columns are avoided. That architects would be loving. Now, load-bearing walls substitute the frame and skeleton structures here, and you get flexibility as in terms of even possibility of custom manufacturing for non-typical shapes and sizes. So these can be designed for easily. This is one very important property. Precast elements can be designed for easy removal and reuse to accommodate future building expansions and renovation, which means you will be again lessening the requirement for building fresh. So this is again another tenet of sustainability. All weather construction is possible, so there is no issue. Plant cast concrete units minimize the weather delays. Then very low maintenance because of excellent material. Then it's environment friendly. We will go a little more into this.
Take less than 5 crores. Don't accept. Even your daddy tell also.
And
Minimum
somebody
5 year plus.
please put off.
Marisa, permit please.
Yeah, sorry.
Okay, now when it comes to economy, there are various reasons how economy can be achieved. Faster construction time, low maintenance, long life, potential reduced insurance premium, all of these contribute to overall savings. And short-time erection, less cost for financing and for site equipment. So your hiring charges for equipment reduces because you are erecting things much faster. Large repetition of elements will reduce overall production cost, less labor supervision, craftsmen, etc. Then lesser shuttering required at site. Precise reinforcing during prefabrication saves steel, ensures exact rebar figures. We all know this. I'm just putting things together. So economically, makes eminent sense to use precast. Precise consumption of all used material per fabrication in a factory, and smooth surface that save the cost of plastering. Only joint filling and paint and probably wallpaper will be used. There are some miscellaneous benefits like pre-fitted doors and windows is possible before erection. Electrical conduits and pipes, etc. can be embedded. The vista of surface treatment is possible by altering the shuttering or form liners or exposed aggregate finishes, sandplastering, etc., etc. Thin precast walls and facade panels increase the carpet area. Better health and safety standards compared to conventional construction methods. So number of benefits are there. Projects can be better planned, managed and controlled. Plant site can reduce transportation distance. If you do the precast at plant, if you can put a precast plant at site, you can tremendously reduce the time and transportation emissions which are there. So you can also increase the speed of erection. So a few examples I just want to flash as far as application is concerned. There is hardly any application which precast cannot answer. Now, primary elements are precast concrete slabs which are used. You can see a solid flat slab, a hollow core slab, a double T and a single T. The greater the span, deeper will be the elements, obviously, as required by the structural mechanics. And you also have these hollow core slabs, which tremendously reduce the concrete consumption as well as steel consumption and easily can span a reasonably good, it can give you a reasonably good column-free space, and also they are light. There are also precast beams which are possible to be provided to support the slabs, and the projecting reinforcing bars will bond with the concrete slab cast on site or the screed concrete that you will put. And you can see on the right side these inverted T beams which are supported by precast columns. Precast columns also can be reinforced columns, or they can be pre-stressed if required, if there is a lot of bending force or something like that. Otherwise, it is generally reinforced concrete precast. So it's possible to adopt whatever system you want depending on the stresses and the mechanism of load transfer. Now these are wall panels, and they can be wall panels can be even made with some kind of insulating core to make it lighter and environmentally thermally comfortable. Wall panels can also be ribbed to increase their stress handling capacity and minimize the weight, and also get some special shapes and so on. It can be used for precast concrete stairs. It can be used for uniquely shaped structural elements like you can see here in a sports stadium. Even assembly concepts vary. Vertical support can be provided precast columns, wall panels, or a combination of all of them. That is, columns, beams, and wall panels can be simultaneously used in different parts of the building. And the choice of roof and floor depends on the span requirements. So precast slab elements are frequently used with other vertical load bearing systems like side cast concrete, reinforced masonry or steel. So many a times people think precast means everything has to be precast. Not necessarily. You can look at the cost effectiveness and convenience and requirements and go for a combination of, as was mentioned, side cast concrete, reinforced masonry or steel along with precast. And even in precast, many a times the junctions, joints can be cast in situ. So there is no need to be saying either this way or that way. It can be a good judicious combination of precast and in situ concrete. So assembly concepts, you can see clearly how various types of solid walls and solid slabs and hollow core slabs are being used in a particular building. You can see a single story warehouse consisting of double T's here, a parking lot with double T's, probably pre-stressed, I don't know. And even some specialized applications like transportable precast houses for areas which are difficult. So instead of carrying all the materials there and you're mixing equipment, casting wherewithal, etc., you can transport small precast houses and simply provide it, especially for lower economic sections, EWS, etc., or at far-flung places, etc. Again, transportation, this is a transportable restroom, which is possible to be taken and directed at places temporarily and then shifted to some other places. So precast is very eminently suited for this. Now you can see it can be provided in stadium arena, like theater seatings or steps or whatever. All of them can be precast. And it's very easy to and faster to implement. You must have heard of the Modera Stadium, or now the Narendra Modi Stadium in Gujarat, the biggest cricket stadium. It's all precast. It's a fantastic example of how precast can be used. So in specialized applications like sound barrier walls, precast rings for chimney stacks, storage and holding tanks, interior firewalls, tunnel liners, industrial pipe racks, culverts of various shapes and sizes, all of these can be precast. Arch crossings, precast pavements. Now it's coming in a big way in the roads. The road pavement, all the slabs you cast elsewhere, if required, pre-stress it, then just come and erect it overnight. Next day, the road will be ready for use. So only this upgrade preparation will take some time. So precast pavements is one application. Curb barriers, wheel stops, and curb inlet gratings, again in the road sector, and water storage tanks, manholes, even small things like cattle feed trough can be made with precast concrete. 3-inch arches for mine, precast arches for mine escape tunnels, traffic and utility tunnels. We are seeing now in metro everywhere, these tunnels are being used. All of this skin shell is made with precast. In railway sleepers, of course, for a time immemorial, we have been using precast crossing panels, ballast curbs, and so on and so forth. And some unusual applications like breakwater pods, compound walls, and facades. You can see how beautiful the facades can be. It is not that it is only plain and bland. It can be colored, it can be textured. Only you have to design the form liners and you have to cast with a little care. And with self-compacting concrete being available, precast it's so easy now. Now, lastly, I would like to come and say how precast is good approach for sustainable construction. Although most consumers are concerned with present and future health of natural environment, very few are willing to pay more for a building, product, or process or innovation that minimizes the environmental burden. Everybody appreciates and they say yes, but then they have to also see how they can contribute. So the concept of sustainability balances the sustainable design with cost effectiveness. Both are required. So using integrated design, which we call also as whole building approach, this is an approach which makes or which helps you to make sure that the building's material, system, and design are examined from the perspective of all project team members. and users as well as occupiers. Now, energy efficiency, cost, durability, space flexibility, environmental impact, quality of life are all considered when decisions are made regarding the selection of a building design. Precast concrete contributes to sustainable practices by these means: incorporating integrated design, using materials efficiently, incorporating SCMs, reducing construction waste, site disturbance and noise, reducing emissions by avoidance of transporting all raw materials to the site, improved air quality at site, etc., etc. So it contributes in a big way to sustainable practices. Now, there are some new trends, which I'll take another 5 minutes to try and finish. The rise of smart precast systems in modern construction. These are the new trends, what will come tomorrow or what has started happening now. Rise of smart precast systems in modern construction, digital transformation technology shaping the precast concrete, and future materials transforming precast concrete. In fact, material science is one of the fastest areas of innovations in precast concrete. It is driving major improvements through the strength and durability. Now let's see all of them quickly. As far as automation and robotics is concerned, the most important thing in modern precast now, of course, automation came to make sure that the manufacturing is accurate and that on-site labor requirements are reduced. So how they are automated here? They are using it for rebar bending and cage welding with robotic precision. They are using it for automated mold preparation to speed up production cycles. Robotic concrete placement is being attempted and compaction for consistent density and finishes. Laser guided dimensional checks to reduce quality control errors. So all of this, FIB has produced one report. It says that by using these automated mold systems, they can reduce or they can increase the production efficiency by 35% and reduce the material waste by 25%. So for large scale projects, these advantages compound to massive savings in time and labor. So that's one advantage. So automation enhances worker safety is another aspect, leading to performing risky manual tasks. Now the workers will only oversee the machine. They will be far away from the dangerous places. So they reduce the exposure to repetitive strain and heavy lifting hazards as well. Another is IoT sensors embedded in precast systems. Now, integration of IoT sensors, these are tiny devices which are embedded in precast components using production and offer real-time monitoring throughout the structure's lifespan. So this common IoTs measurements which include concrete moisture levels, temperature variations, crack development movement, load and stress patterns, vibrations and traffic impact, all of these can be measured and monitored. So this will help in a big way in predictive maintenance instead of energy maintenance. So the integration of smart sensors represents one of the most impactful innovations in precast concrete, enabling real-time structural intelligence. Now this is a typical instrumented road slab. I'm not getting into the details of this. And then smart molds and digital fabrication tools. So the digital fabrication is making it easier to produce customizable precast designs. So smart modules are using programmable forms which automatically adjust the dimensions, curves, and design features without needing full manual rebuild. So these tools will allow for faster prototyping of complex architectural elements, greater design flexibility, reduced labor time for mold adjustment, and precision that meets modern engineering demands. So this combination of speed and accuracy supports both mass production and high-end architectural builds. So these continue to push the innovation of precast concrete by allowing faster prototyping and greater customization. Now under digital transformation, this BIM already people are talking about using of BIM for seamless design and production. That has entered the precast area also. So BIM helps the teams to collaborate efficiently from concept to installation to avoiding delays and costly reworks. So BIM helps by 4 means. One is clash detection. that is clash between pipes, cables, and structural elements, is detected very quickly. Shared 3D models. 3D models can be built, made, and shared with architects, engineers, and contractors for better understanding. Accurate quantity estimation can be done and prevent the material shortages, and precise lifting and installation planning can be done. So there is a McKinsey report which says full BIM integration can reduce project timeline by 20%, 10%, and minimize construction waste by up to 20%. Isn't that sensible for sustainable construction? For precast, the benefits are even greater since components are prefabricated at site, off-site, and require near perfect coordination. So there is another concept called digital twin. So whatever is being constructed, you are creating a virtual real-time replica of the physical structure. So using data from the sensors and BIM files, digital twins will allow the owners and engineers to simulate and monitor how a structure will perform over time. So they are very useful or impactful in bridges for monitoring vibration, weight loads, crack development, etc. Tunnels for tracking moisture, airflow, and structural shifts. Highway systems for smart pavement monitoring. Large buildings for energy efficiency and structural health, etc. So digital twins increase the lifespan predictions, reduce inspection costs, and support more sustainable decision making. Now, artificial intelligence, that's how can I end without talking of AI. So now AI powered quality control is becoming a game changer in precast plants. Cameras and scanners are equipped with machine learning that can detect surface defects, air pockets, textured inconsistencies, and dimensional errors faster than the human eye. So AI improves the productivity in precast. I'm talking only application in precast. Automated defect recognition on fresh and cured concrete, real-time reporting for immediate corrections, predictive analytics that identify and the recurring issues, consistent quality control across large production volumes, etc., etc. So AI-powered monitoring represents a significant innovation in precast concrete, improves accuracy and reduces production waste. As far as material is concerned, one or two materials I would like to take here. One is the ultra high performance concrete. Now everybody is talking about it. This is one of the most celebrated innovations. UHPC provides a compressive strength levels exceeding 150 MPa, more than 3 times stronger than typical structural concrete. So the benefits because of UHPC are as follows: longer spans with thinner sections, superior durability and abrasion resistance, minimal maintenance requirements, extended service life for bridges and infrastructure. A few more slides on UHPC because this is also a favorite topic of mine. So it's a high strength ductile material, concrete. It's a high strength ductile material formulated by combining Portland cement, silica fume, quartz floor, fine silica sand, high range water reducer, water, and steel or organic fibers. It's also called as reactive powder concrete. Many years ago, this was produced even in India. And now a lot of people are attempting to use it in their structures. And it's very ideally suited for precast. So typical, material requirements, you will see that there is no coarse aggregate in this. So that is the beauty of this. That's why it is called reactive powder concrete also. So if you see the packing density, people are focusing more on packing density. The least void is something that they're attempting. So what you see on the top half is the UHP FRC, that is your ultra high performance fiber reinforced concrete, or UHPC to be short, and the conventional concrete. So you can see that there are virtually no voids, and hence it is a very densely packed material. Denser the material, stronger it is, and more impermeable it is. So the salient features are like this. As a class, UHPC is a high cementitious material and very low water cementitious material ratio. It can be mixed in conventional mixers, but requires a little longer time for conventional. A lot of fibers are used, mostly metallic fibers, and the method of placing has an influence on the orientation and dispersion of fibers, because the fibers can move in a flowing concrete and align parallel to the flow. The properties of UHPCs are affected by the curing regime also. I'll not get into all of this. So in essence, it has high compressive strength. It has ductility in the post-cracking stage. If you see the comparison, blue is for concrete, the red one is for steel, and you see fiber reinforced concrete, UHP FRC, is having much higher. It even shows some amount of strain hardening and very large area under the curve, which means the toughness is much higher here. It has an internal crack bridging capability. It has dimensional compatibility. It has essentially zero permeability and hence long lasting, excellent bonding capacities. This is something which is very unique to UHPC. Abrasion resistance similar to rocks. So if you see the comparison, you will see that the blue one on the right side has the least oxygen permeability, chloride ion penetration, water permeability, reinforcement, corrosion rate, and carbonation depth. So because of all of this, it makes it possible to produce thin, complex shapes, curvatures, and customized textures and concepts that were earlier difficult. Now it is easy to provide that. So major impediments in precast application was transportation and erection. And because precast made with UHPC is stronger and lighter, the issues are more or less assuaged. Lighter structure would save foundations and reduce seismic demand on the structure as well. Precast made with UHPC would be more durable due to nearly zero permeability. It is an excellent adhesive, very useful to join precast elements. This is another. So you can see here precast bridge element being lifted and put in place. Very easy to lift this because it's lighter. You can see some huge retaining walls, but the thickness of the retaining wall is just 40 mm because it is made out of UHPC. You can see how easily it is precast and it can be directed at site. This is a UHPC facade for a building and it is that facade is about 0.5 to 1 meter wide, 3.5 to 5.3 meters height, and the thickness is only 30 millimeters. So you can imagine how light that material is, and it can be used very easily for all of this. These are all uses of UHPC facades. As a joint fill, I said, if you have two precast members to be joined, just pour the joint with this UHPC and it bonds far better than even that precast which is there. So this is something that is used. And the other one people are talking about is carbon cured concrete. Carbon curing technology means you have to, instead of traditional steam curing, carbon dioxide is injected into the concrete during curing, where it becomes permanently mineralized. So up to 30% reduction in carbon footprint, stronger early strength, faster curing and production cycle, compliance with green building standards, all are possible with carbon cured and carbon negative precast. People are also talking of self-healing concretes, a little far away, but still it is possible. We have bacteria-based healing, microcapsule-based healing, and shape memory alloys, and so on and so forth. So this reduces the maintenance expenses dramatically and is ideal for tunnels, bridges, and remote installation where repairs are difficult. So last is what is required to popularize precast construction in India. Increased mechanization in manufacture and assembly, modularity and possible repeatability. The more modular it is, more repeatability opportunities are there, more economical precast will be, which all of us know. Transportation issues, the equipment, the trucks and other logistic requirements for transportation issues, and then the need for speed and volume. We have to build up the volumes and speed, then it becomes economically viable. Availability of skilled workforce has to be ensured. A lot of training is required. Modularization in individual houses are also possible to be tried so that precast can be implemented in this sector. Right now, in individual house sector, there is virtually no possibility of precast because nobody believes in modularity. So everyone asks for different sizes, and then combination becomes a little difficult. Solving the issue of hub and spoke model. There is, if you want to make one factory which makes all the precast component, and you want to supply it to nearby places within, let's say, 200 kilometers, what is important is the road. So the road network should also enable this, and facilitating road network and transporting of the elements should be ensured. 3D modular is becoming again big, especially in Singapore and Australia and other places. The entire house is pre-fabricated at factory, and it is lifted and taken there and assembled. 2 or 3 modules put together will become one full house. It has been tried in many places, even in India, but it is still, this is basically called as prefabricated, pre-finished volumetric construction, PPVC. This is going to come in a big way, and with UHPC, this is definitely possible. And a clear understanding of jointing mechanism and sealing of joints is very essential, because one of the big complaints is that it leaks. So that is bringing bad name to precasting. Precasting is not the problem. The problem is the jointing mechanism and sealing joints. Jointing mechanism also becomes very important for seismic resistance. So in conclusion, construction industry has a large role to play in sustainable development. Concrete being the most ubiquitous construction material, it is necessary to make it as sustainable as possible. Precast concrete represents it presents a compelling solution for reducing the carbon footprint of construction industry, and it allows for efficient production, lower emission, and long-term durability, making it a key component of future sustainable construction practices. So innovations include BIM, digital fabrication, high performance, lightweight mixers, insulated sandwich panels, smart embeds and sensors, automated production. All these advances improve the speed, energy efficiency, quality control, helping the builders to deliver stronger, smarter, and more sustainable structures faster than the traditional methods. So the drive towards more sustainable construction is achievable only when all the stakeholders in the industry, including developers, designers, builders, suppliers, all of them recognize and appreciate the importance of sustainability in construction. Thank you very much for the opportunity. I am humbled that I got this opportunity to speak in memory of Dr. A. Ramakrishna. Thank you all, gentlemen.
Great, sir. Congratulations, sir. Great, sir. Highly appreciable talk, sir. Really, we're proud of you, Dr. Kalagal, sir. Some eminent engineers from USA, sir, Dr. Ramakrishna Rao, sir, wrote in chat. I think you have seen this.
Sir, I have a question.
Yeah, kindly. Dr. Ranjit, sir, go ahead.
Sir, actually, you are having the background of post-tensioning of structures and precasting and all. How is the entry of 3D printing in the precasting yards and all? Because see, for post-tensioning and precasting, molds are very important. And when you are going away from the molds, when you are using 3D printing, is there any firms or the method? Because parametric architecture, as you said and mentioned, is going to be very, very, and not only in the parametric architecture in the facade, but you are using the parametric designing in the element design itself, variation of the sections, not like a beam earlier by rectangular section and all. So how this 3D printing is going to affect this thing? And sir, what about the material? Because you are from the material science, so UHPC and all, but what exactly the grade of 3D printing they go, and what exactly the development is required for the 3D printing to be used in general?
Quite many questions combined in one, but the essence is the focus on 3D. Now, 3D printing is a technology where generally we avoid using reinforcements, and they try to make the material itself, like using fiber reinforced concrete or materials which are capable of handling things by shape rather than by bending. So most of the bending elements are avoided, but there is also another concept that you can precast, or you can cast in some place lot of elements which can be assembled to make it into a building. Of course, that is the approach which the Chinese started. Everybody started saying, when they said that they are building a house by 3D printing, what it meant was they cast elements of reasonable dimensions on the floor or on the mold using 3D printing techniques and assembled them in some form or the other. So that is one approach. The concept of pre-stressing this, I haven't seen yet, but the issue is, see, only post-tensioning has to be done. Pre-tensioning can't be done because you can't stretch the wire and cast the 3D around it. It's a little involved. Right now, I have not seen any application, but it may be a good idea to pre-stress them in the vertical direction just to make sure that these elements don't move around, etc., etc. So it is still in the evolving stage. And as far as material is concerned, UHPC also is being tried where there is sufficient amount of fibers which will handle the bending part of it. And also the casting of these things depend on several factors. Suppose you have a huge building, then you have to fabricate a huge machine to deliver the concrete through the nozzles to all places and come back. So it becomes difficult, and you have to engineer the frame itself for, especially when it goes to multi-storied, it becomes a bit involved. So what I was told in some countries, Spain or somewhere, they have now planned climbing robots. You know, this they climb on the concrete which is made, and they lay the next layer, and then they start going up. So you don't need a huge frame for casting. So a lot of requirement or interplay between architects, structural engineers, and the material scientists are required in each project. There is no one thing that fits all. So that's all I can say.
Yeah. Yes, sir. Thanks, sir.
Sir, I have one question.
Sir.
When we talk of 3D printing.
Can you introduce yourself, please, sir?
Yeah, I am Dr. Bhaskar Bhandapkar, Chairman of Center Coordination Committee and member of Asia Pacific Industry Engineering Board, Japan.
And sir, also our former Joint Honor Secretary from Hyderabad, Erstwhile Andhra Pradesh.
Good, sir. Sir, go ahead, sir.
Yeah.
Kindly, sir.
So when we talk of 3D printing and construction, there are basic issues involved. If we go for metals, the shrinkage of the material is one of the important issues we have to consider. And second thing, if you consider the screw deformation under load, that is another issue. Third issue, from the safety point of view, when we talk of twinning at higher temperature, the twinning is the primary cause of accidents or deformation. So what are your opinion on these three things?
Yeah, I fully agree that the thixotropy of the material, the squeezability of the material, and then the capacity to resist shrinkage to a large extent all matter. But there are issues. There are even issues of creep that are there when you go for taller elements. So just like we used to do in brick masonry earlier, we would not cast more than 4 layers at a time. So, then we would allow for it to mature and allow for it to take the further loads. Some similar approach is generally tried. Nobody tries to build it continuously for 1 or 2 days, things like that. The gaps are given. I have seen people waiting for some time for it to achieve the strength. So one is the immediate strength, that is the strength of the lower layer when the upper layer starts getting put on that. So there are issues, but then with the use of higher grade materials, these are more or less handled. I'm not saying that it is completely solvable, because if that was the case, then everybody would have started building. Now everybody is building only to showcase that they have done in 3D. After doing that, where is your second project, third project? Nobody is answering. So there is still a lot that needs to be understood, especially about the material, because the material needs to be designed for the speed of the nozzle, the size of the nozzle, and the rate at which the layer is being laid, and thickness of the layer, so on and so forth. So there are many, many unanswered questions, and I don't have answers for all of them. Nor am I a producer.
Thank you, sir. You answered very nicely. Thank you very much indeed.
Dr.
I have got a
Ramchandra from
question, sir.
USA. Dr. Ramchandra from USA. Ramchandra garu, అడగండి, please. First.
Sir, good
Sir,
evening.
you need.
Very nice presentation. I am in USA and I see a lot of precast works. But in Indian context, there could be two problems. One is transportation. Suppose if we want to transport a 40 meters precast pre-stressed beam for a bridge, I don't think we have we have trolleys and we have roads. The second is the damage at corners and edges due to handling and transport. Those give rise to leakages. These are my concerns. One is the presenter has at one point used well-trained masons. In my 37 years of service in public works, I could not demand a differentiation between first class mason and second class mason. The man who holds a trowel is a first class mason. So there should be a sort of certification. And sorry to say, in my 37 years, I could not make a wall complying to English bond because no one knows, neither mason nor engineers. These are the actual field conditions. And for the benefit and aid of the presenter, I posted 2 Supreme Court relevant cases where development is placed over or at least on par with on par with environmental protection. You name a project, the next day you find a PIL challenging the project. So this keeps sustainable development at least on par with environmental protection as long as safety measures or some concerns are addressed. Thank you. Once again, thanks for good presentation.
Taradil sir.
Sir, I have got a question, sir. It is a very, very nice and very informative presentation. A lot of thanks to Dr. Kalkal sir. I am architect Tara Prasad Dhal. I am from Odisha, Bhubaneswar. I've been patiently listening to your presentation, and mostly I am very much fascinated with a long span flexibility. And number two, the construction waste is reduced by this way. But the parametric facades and parametric constructions, particularly in 3D way, not in a linear way, that is a limitation in this type of structure. So can I get some little more details on this?
Yeah, okay. Thank you for your interest. Basically, one issue that you are talking of is the 3D or in 3 dimension, the variations which are a challenge to precast. So this is where the 3D printing probably takes over, and it can give you those curves and things which are little easier to provide in a 3D printing route. Whereas when it comes to precasting in a factory, the cost of developing a mold for the different shapes and different sizes takes away a lot of your effort in terms of feasibility as well as economy. So again, it's a question of volume and repeatability. If there are 1,000 such pieces, now there are people like Abhay Gate in Pune, they are all making facades and things like that of various shapes, unimaginable shapes, which you think precast can't produce. In fact, one of the slides I showed the facades which had all kinds of architectural finishes, and it's only when you move away from rectangularity, when you move to curves, the formwork takes over and creates problems. So what people are trying are fabric formworks now. Now fabric formworks are flexible. You can prefix the shape and pour concrete into it. In fact, Christopher Benninger himself has tried a lot in this particular area, and a lot of people are now using fabric formworks. So you don't have to have a prismatic shape. It can be curved, it can be even having your bending moment profile and all kinds of things. And it can be cast. And the surface of that, you can treat the formwork inside so that when it comes out, it will have, I had a lot of photographs, but I have restricted. But it is possible, sir. Of course, formwork is an important issue. It can be a limitation also sometimes.
Hello. Hello.
I think Nagendra is raised.
Yeah.
Yeah,
Nagendra from Bangalore.
Yes,
I want to just compliment. It was a very well organized and well structured presentation, having a lot of information, especially from the beginning, the sustainability aspects, where we stand India in the world context. Surprised to see America and Canada put together are really harming the environment than what India with a 130-40 crore population, more than 100 crore. That is one aspect. Coming to precast, I am really looking for a day where I can use the precast to build a house with very easily, transporting them to a place where I want to, or where whoever wants. Because 1992 we did national games. Those days Biji Shirke were the pioneers. They did a lot of precast things. From that day to till today, we are looking for, we do not have a solution or do not have any ready-made fabricator who will supply. I want to build one. If I ask, there are many questions. There are many things which really cannot do for a single house. I'm telling, single. It can be a row house or anything. People have done in Bangalore also. Very big precast factory was set up by Shapurji. That was the only one happened, and later on we did not hear anything from Shapurji also doing much work in that area. So we see a lot of WhatsApp videos, LinkedIn videos and all coming from China. They do everything so easily. Very European countries, they build house immediately, they dismantle and take it to another place. But when it comes to India, we are really unable to give a solution in this regard, because many of my friends ask, I want to build, give me a solution, can you do it? These things, I think we all engineers need to, concrete professionals need to address this and to look forward something positive which should come within next decade or within 5 years or something. So very good presentation, sir. Thank you very much.
So last question, sir. Anybody last question, sir? Let's go for conclusion. Damod Saab, Murthy garu.
Yeah, Mr. Varghese, Anita Varghese, Miss Vargita Varghese.
Yeah. Kailash garu, will take a seat. Unmute.
She has to unmute.
Yeah, Anita Varghese, unmute kar dijiye. I think.
Okay.
Yeah.
She raised her hand and then she said bye bye.
Yeah. Anita Varghese, unmute yourself.
Our precast man, C.A. Prasad garu.
Precast man.
In the meantime, we can say.
Yeah. Prasad should not ask questions. I am scared.
All right, let me give you some information.
Yeah, you can give.
Right. Say someone is talking about long trucks are required for long beams and all that. But in Hyderabad, a firm by Inventa Industries have already done about 28-meter long elements and 24-meter long elements weighing 88 metric tons. 24-meter high column, 8-story. The 88 metric ton. They used a 500 metric ton crane, mobile crane, and lifted in place. Similarly, 138 metric tons, 28-meter long, about 2-meter deep beam is lifted in place. It is not that India is lagging behind. Yes, they are also doing lots of wonders. And as you rightly said, Dr. Kalagar, yes, people, like if you look at Infosys car park in Pune, is a wonderful structure where Precast India infrastructure have done a beautiful facade outside with a concave and convex elements, one over the other, allowing the ventilation to go inside. And they have employed about 3 architects from abroad and then chosen one of that particular thing. And of course, Infosys is also fantastic in providing only 17 crores only for the facade element. When client is there, yes, precast is also there. Okay, nothing is impossible. Now we are also looking at in Hyderabad. Now there is a developer by my home where they are building about 40 million square foot in precast. Okay, they are doing 6 basements down and 34-story high. Like that, they are building about 8 towers, and it's a huge construction which is coming up here, right? And if you talk about in Delhi, I have designed for DRDO, Delhi, which is a zone 4, where we have constructed about 8 lakh SFT, still plus 8-floor building for DRDO. And my friend Mr. Bob Wills have designed for in Ghaziabad a 16-story precast building, okay, residential building. Like that, buildings are coming up, right? And the testimony of that is my home building a huge 34-story precast structure. Like that, I am trying to push as much as possible in the government sector also. We are doing some institutions in precast in the educational departments. And for GHMC in Hyderabad, we built about 11-story precast buildings of about 14 towers. Okay, like that it is coming up. And in Ahmedabad, they are doing a lot. And if you are looking at Mumbai and Ahmedabad, the expressway, all along the route, wherever the villages are coming up, they are building about 1 to 2 kilometers of precast compound walls around that. So only to see that the sound will not propagate into the villages when the train moves. That's all with precast. And L&T have taken about 5 precast companies only to produce precast compound walls and the columns and the panels, including the precast footing. Okay, that's how precast is developing. And yes, now there is a shortage of skilled force. We are trying to see how best to do that. I'm also introducing a subject called precast subject at 2 levels at Vijayawada, Siddhartha University, as well as my ex-colleague Mr. Pawan is also teaching in Mahindra University here. We introduced the subject, ensuring that precast engineers comes up and then take up the design and all.
Yeah,
thank you.
Thank you. The chairman, sir, Anita garu vacharu.
Yeah. Anita madam, please.
Thank you so much, sir. So here, I want to tell you about the advantages of 3D printing concrete. Is a very we all know about the 3D printing now, but the thing is that it is for precasting also it is too good. The thing is that the wastage of materials is very less, and the cost of construction time is also very less, and it can be used in a large scale productions can be done in a very effective way. Suppose in a calamity areas, if you want to construct 100 houses or something like that in a very random way, it is very easy to do that. The only thing is that it has to be the initial cost, the equipment cost is too high. That is the only criteria. And also, the thing is that no such standardized codes are not available. Unlike the conventional concrete practices, we don't have the 3D printed concrete is not having the codes and practices and the limited availability of printable concrete materials. There's also the reinforcement techniques are also very limited. We are not supposed to use the common reinforcements for this 3D printing. We have to use, as the Professor Sir said earlier in his wonderful speech, and he explained about that fibers are used for the reinforcement and the printing. It is very important that the rheological properties has to be maintained in 3D printing, like yield stress, thixotropy, plastic viscosity, all those things, and the build-up, the structural build-up, all those things has to be very much taken into account, and we have to do accordingly. So I wanted to just say about a few things about this 3D printing, since I am pursuing my PhD. So I was very delighted to learn about this 3D from sir. So I wanted to tell something more about what I have learned this period. That's what. Nothing else. So 3D printing is very good in precast concreting. It is very, very effective. I think in the future is laid out on this 3D printing. Thank you so much, sir, for giving me this opportunity, this platform. Thank you.
Okay, thank you. Good, badhiya. Thank you.
Thank you, sir.
Dr. Ajit Saab, let us go for any last question. Anybody there? Let us go for vote of thanks by Honorable Secretary. Honorable Secretary, propose vote of thanks. Sir, once again, congrats, sir. Dr. M.R. Kalgal, sir. I also did my ME structures in FRC, fiber concrete, by Professor Badruddin, sir. Dr. Ajit Saab knows it.
Yeah, correct.
Honorable Secretary.
Thank you, Chairman. Thank you, Chairman, sir. I thank our Chairman, Professor Dr. Ramanayak Bhanatu, Chairman of IATSE, for giving me this opportunity to propose vote of thanks today. On behalf of the Institution of Engineers India, Telangana State Center, I, Engineer Mari Ramesh, Honorary Secretary, deem it a great privilege to propose this vote of thanks for the Dr. A. Ramakrishna 13th Endowment Lecture. We extend our profound gratitude to our esteemed keynote speaker, Professor Dr. M.R. Kalgal, President of SCWC India, for his illuminating address on sustainable construction and role of precast concrete. We place on record our sincere thanks to our Chairman, Professor Dr. Ramanayak Bhanatu, and express our deep appreciation to Captain Dr. Bhaskar Bhandarkar, the Chairman of the Marine Engineering Division IEI, and also the Chairman of Member Coordination Committee of IEI. As well as we thank Dr. Engineer Architect SP Anchuri, the convener of this endowment lecture, alongside all the distinguished dignitaries and fellow engineers for their invaluable presence and support. We have, as rightly said by our convener of the day, Dr. Engineer Architect SP Anchuri, we have participants today across Pan India. It is not only from across Pan India, we have participants from like our Ramakrishna from USA and one more friend from UK. So we have few countries also participated today. It is great honor to the IITSE. So we have some dignity with us. It is proud privilege to recognize the presence of Dr. KGK Murthy sir, Engineer Ranganatham Garu, Engineer AKM Alam Khan, Engineer Akshay Shaini, Engineer B. Ravikant, Engineer Bharati Ganesh, Engineer C.A. Prasad sir, Engineer G. Raghava, Dr. B. Ravinder, Dr. Babu Srinivas Reddy, and Dr. S. Murali, Committee Member, Professor Dr. Muhammad Mainuddin, Committee Member and Joint Honorary Secretary of IITSC, Engineer G. Damodar Reddy, Engineer K. S. Srinivas, Engineer M. Vijay Lakshmi, Engineer Magesh Kumar, Engineer Meghana, Engineer Miss Anita Varghese, Engineer R. Narendra, Engineer Dr. Narmada, Engineer Nilesh Singh, Engineer Puneet, son of Dr. Padri Srinivas Reddy, Professor Dr. N. Shirisha, Engineer Raghunath, Engineer Ramakrishna Rao, Engineer B. Jagadish, Engineer B. Ravikant, Engineer Balachandra Patel, Engineer Saitanuj, and Engineer Shalavanam Palivelan, and Engineer Sashi Ranjan, Engineer Sridharasiyan, Engineer Sivananda Yedi, Engineer Sundari B, Engineer Surendra, Engineer Sushil, Engineer Tara Dalsar, and Engineer Uma Venkatramana, Engineer Umesh, Engineer Vamshi, Engineer Venu, and many others. So I thank all of them for their valuable participation. If I miss anyone, I'm sorry. And some names are with the phone numbers notation is there. So sorry. So thank you, Chairman, sir. Now it is national anthem. Chairman, sir.
Go ahead, national anthem.
I request all of you to kindly raise for. Okay, Chairman, sir.
Yes, go ahead.
So I request all of you to raise for our national anthem, Janaganamana.
Janaganamana जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल गंगा उत्कल जलधि तरंगा तव शुभ नामे गाहे तव शुभ आशीष मागे गाये तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Jai Hind.
जय
Thank you, all of you, sir. Thank you, all of you.
Thank you so much.
Thank you.
Thank you so much.
Thank you, sir.
Thank you.
Thank you, Dr. Kalgal sir.
Thank you,
Thank you.
sir. And thank you, the precast man of India, C. Prasad Garu.
Thank you, Dr. Ramana.
Anjali Garu, Karuna sir, thank you. Good night, all of you, sir.
All.
Namaskar. Namaskar. Anita Varghese, madam, you became member instead of engineers.
I'm already a member, sir. Maybe.
Okay. All your students also kindly.
Yeah. I am an adjunct professor working in the Rajagiri School of Engineering and Technology,
Oh,
Cochin,
Cochin.
Ernakulam.
Congrats. I have been to Manila by Varghese areas only. That's why I remember your name.
Okay,
Congrats.
sir.
Yeah,
Okay, sir. Thank you so much.
అందరికీ నమస్కారాలు. Wind up. Ratham garu wind up చేయండి. Congratulations. Good night.
Good night, sir. Good night.
We'll come Kochi, ma'am.
Yeah, sure. Very,
Mr. my
welcome, sir. Welcome. Please inform me before your arrival. Everything will be done. No problem. No problem.
Good day.
Okay, sir. Thank you. Thank you so much. Okay, bye.
రత్న గారు క్లోజ్ అయిపోయిందా రత్న గారు? రామారావు సార్ గుడ్ నైట్ సార్.
అన్నా రమణ అన్న,
అన్నా
నేను వేణు, ఒకసారి మీ వాట్సాప్ నెంబర్ ఇవ్వండి, నేను మాట్లాడతా.
93464
ఒక్క నిమిషం నోట్ చేసుకుంటా.
93464
93464
0
0
4684.
4684. ఓకే అన్న, నేను ఖతార్లో ఉన్నా, నేను వాట్సాప్ కాల్ చేస్తాను.
కథారునా వెరీ హ్యాపీ. కంగ్రాట్స్. థ్యాంక్ యూ. సింగబోయిన రమేష్ గారు నమస్కార్. సింగబోయిన రమేష్ సార్ విత్ ఫ్యామిలీ కంగ్రాట్స్.
థ్యాంక్ యూ సార్.
ఫోన్ చేయండి సార్ అప్పుడు.
ఓకే సార్.
నర్మదాజీ టుమారో మార్నింగ్ 9:30 we are meeting Uma Venkatramana.
Yes, sir.
Mr. Prabhu, Anmol Prabhu, smart. Narada madam, 9:30 Tumala itiki.
Okay, sir.
Come with all population and everything, okay?
Sure, sir.
Davana, thank you, good night. So let us close, sir. Good night, all of you. Thank you. Andarki namaskaralu. Thank you for joining. Ramesh sir, ekkada Singapore unna? Ramesh sir?
సార్.
ఎక్కడి నుంచి మాట్లాడుతారు?
సార్ ఇన్ఫోసిస్ దగ్గర నుంచి సార్.
నా నంబర్ ఉందా? మీరు ఒకసారి చెప్పండి నంబర్.
నేను తీసుకుంటా సార్.
93464 046
సార్. 93464
04684
04684
రింగండి సార్.
84 సార్.
ఇన్ఫోసిస్ లో చాలా సార్ నా బ్యాచ్మెంట్స్. శ్రీనివాస్ రెడ్డి వెంకటరమణ ఫ్రమ్ జేఎన్ ఢిల్లీ. 93464 046
96464
93464
93464
04684
4684.
ఓకే రింగండి సార్. థ్యాంక్ యూ.
ఇప్పుడే ఇస్తా సార్.
Thank you, sir. Very happy. Infosys family friends, sir. Venkatramana from Delhi.
93464. 93464. 04684.
Yeah. Very happy, sir. Sir. Got it, sir. 98491 00477. Got Ramnagar. Ramesh sir, got it. Yeah, Ramesh sir, got it. Thank you. Everyone. Okay, Thomas, good night. Thomas sir, good night. అందరికి నమస్తే. Thomas sir, వస్తున్నా మీ ఇంటికి నల్లగొండ బయట ఉందా?
చైర్మన్ సార్ గుడ్ ఈవినింగ్.
గుడ్ నైట్ నాకు గుడ్ ఈవినింగ్. వస్తున్నా, శాంసంగ్ పేరు పెట్టారు SM306 వస్తున్నా. ఇంటికి ఉన్నారా?
అవునా రండి.
పోయినప్పుడు నమస్తే పెట్టేస్తారు సార్. కమింగ్.
ఓకే.
థ్యాంక్ యూ అండి, థ్యాంక్ యూ, లవ్ యూ. So, okay, Thomas sir, good night all of you, sir. Now we are